Okay, so what's the first step? Guys, up here. What would the first step be? Factoring. What do my factors look like?
This is my.
So you have x plus 4 and x subtracted by 4. There's x.
Do you know how to do all that?
And then you just get out. Actually, wait, what? Just factor the bottom one. Which is what adds to 3.
You can do that?
Okay, that's what I saw on all your papers, yeah?
Yes.
Any questions?
Oh, look, there's a hole.
Oh, look, there's a hole. Oh, look, there's an asymptote. Okay. So we could reduce that one, right?
Paste it in there later.
And rewrite this as x minus 4 over x minus 1. Zeros. What is another word for zeros?
X-intercepts.
X-intercepts. How many people remember that?
It's okay.
Jay?
You can do that.
Cool, cool. This is your x-intercepts, which are?
Or, comma 0, because it's a coordinate point.
Oh, yeah, that's right.
Because we set our numerator equal to 0. Why then is it not also the minus 4, the negative?
Like, cancel out or reduce.
Because it reduced, because it was what is that called?
A hole.
It was a whole, it was an excluded value. So even though you could probably say there was a vertical, or sorry, an x-intercept at -4, there's not. Because -4 is an excluded value. Wrong. This is my only x-intercept from here. Okay, what about your y-intercept?
Again, 0, right?
Oh, 0, 4.
0, 4. And we found that by
Plugging in 0 for x.
plugging in 0 for x. 0 minus 4 divided by 0 minus 1 equals 4.
4 over 1, but then it's just 4.
Yeah.
Only put it in a point.
Yep, exactly.
Also, right, like x equals
You have to
4,
accept that.
or is that not the same as our other ones?
Look at all those.
It's not.
You have to have changed.
For intercepts, they have to be in coordinate points.
Wait, that was a dumb question.
Okay, your vertical asymptote, which one is it?
1.
Just say it's not loading on yours.
X equals 1.
X equals 1 because someone else?
I would.
Yeah.
Because the exponents are the same, and there's 1 in front of it, like, so 1 divided by 1.
Okay, that would be your horizontal asymptote, and that was absolutely correct. Vertical asymptote, why was it 1? Yeah.
Is it because it didn't remove?
Yes, it's x equals 1 because it was the non-removable discontinuity. It was the excluded value that we didn't reduce
Because it can't be removed.
because it cannot be reduced. So that means that our other discontinuity was the removable. So what was the x value of that ordered pair? How do I find the y value? Someone. Yes, you did. Thank you, Drake.
Plug 1 in for x.
What?
Plug 1 in for x in the equation.
Plug in the -4.
Oh, the negative, yeah.
Yeah. Yeah, you meant the excluded value, right?
Yeah.
So the excluded value that reduced we plug it into the simplified equation. So we would have negative 4 minus 4 over negative 4 minus 1 equals negative 8 over negative 5, 8/5. Any questions on how I found that? Yeah. Okay, so the whole, do you understand that the whole is at the negative 4? Because it's the excluded value that was removed, right? So to find it, I take that excluded value and I plug it into the reduced, the simplified equation. If I were to plug it in here, it would give me a 0 error. So once we cross those out, I can plug it in here to give me the 8 over 5, the y values. And then we said horizontal asymptote was y equals 1. Sam said because the degrees are the same, so you divide the leading coefficients 1 over 1. So let's sketch it. Start with your asymptotes. X equals 1. The horizontal asymptote was y equals 1. Did I do something wrong? Did I do something wrong?
I'm not even listening.
Oh, good.
I'm just kidding about.
And then put in your intercepts, which was 4, 0, and 0, 4. There's also a hole at negative 4, 8/5, which is slightly above the 1. What would I do from here? How do I finish this? Yeah. You.
Okay, you do like a table and then you put X values in and then you put X values in the equation for X.
Good. What if I told you that there's an easier way? Would you be excited? Yes. Sorry. Brain fart. Did anyone do that already? Okay, I already have 2 points over here, right? I have that hole and that intercept. So if I were to connect these lines, it would look like this. I know I'm not going to cross this vertical asymptote, so it's just going to go up from there. And I know that this end behavior is going to match up, get very close to, but not touch this horizontal asymptote. So I already know that side looks like that. Do we agree?
Yes.
Okay. This side has an intercept right here, right? Is it going to cross that vertical line? No. So what do you think is going to happen as it comes this way?
Just gonna like go parallel with it kind of.
Yeah, it's going to go down towards that line. Going this way, same thing. It's horizontal. It's not going to cross. Yeah. Huh? Yeah, we can do the domain. To there. Yeah? So that's a lot easier than doing the table, right? Okay, there's another way too. And then the domain would be, you start with negative infinity. You go to the smallest excluded value. What was our smallest excluded value? Negative 4. And then you go from that smaller value to the bigger one. What was the other one? 1. And then 1 to infinity. So this is saying is the lines are going from negative infinity to negative 4. So there's a solid line from here to there. And then from negative 4 to 1, where that line is. And then 1 to infinity. Yeah? Make sense? Good. So we're going to keep doing what we've been doing, but we're adding multiplicity. But don't get scared about the multiplicity. Be happy, because this is our trick. This is how we're going to find out where our lines go without using the table. So what about multiplicity? Yeah. What? The domain? Oh, the table? Oh, sorry. I got really loud. I couldn't hear Steven.
Oh, why didn't we write down the table?
We wrote down the table because that's how we did it before. If you weren't sure where these lines were going to go, you would plug in an 8 and find like a point like right here. And that would tell you where your lines would go. But we just kind of used reasoning to say like, oh, this isn't going to cross up there, so it's just going to go along with it. It's not going to cross, so it's going to go down with it. So what did we see when we found multiplicity before? Yeah. With graphs of multiplicity, we saw bounces, right? If it was a even multiplicity. What else did we find with multiplicity? How did we find multiplicity? What about on your equation? How did you know that there was multiplicity? There was exponents. Good. Looking at this equation, x to the 5th minus 6x to the 4th plus 9x to the 3rd. How many zeros are there going to be? 5. Good. Because it equals the highest degree. Yes. So let's factor this. What? Oh yeah, we can factor it. It's okay.
GCF first, Miss Hooper.
I didn't see the last number. What will it look like? Blah. Yeah, pull out x cubed. Good job. And then we have x squared minus 6x plus 9. Now we can factor this. What do we have?
Negative 3 twice. Negative 3 cubed.
Squared. Now, what are our excluded values? Our zeros, our products?
3 multiplicity.
Yeah, there's 3 multiplicity 2 and 0 multiplicity 3.
Good job.
Do you see where we got that?
No. Did not think anyone would get that one.
That was really good. Huh?
She didn't show the add to negative 6 multiplied at 9.
You're good or?
Just draw the puzzle for the at blank plus blank negative 6 and blank times blank 9.
Oh, that's
This went a little too fast.
Yeah. Yeah. Oh, yeah. Yeah.
Squared. Yep, so you could write this as x minus 3, x minus 3. Somebody said it, so I just wrote it down. Yes?
Where did you get your multiplicities?
Multiplicities are, there's a squared here, so the excluded value is what we've been thinking of, but this isn't on a denominator, so it's not an excluded value. The solution would be 3, but there's a multiplicity of 2 because it's squared.
Oh, okay, that
Yeah.
makes sense. So you just like equal what's in the parentheses to 0,
Yeah.
and you get that. Okay.
Yep, that's the zero product property.
Okay.
Set all of your factors equal to 0.
0 multiplicity 3 came from the x cubed, right?
Yep, if you set this equal to 0, you would get x would be 0, multiplicity 3. Any other questions?
Wait, what about the 0 and 3?
Yeah, so if you set x equal to 0, x cubed equal to 0, it would be 0, but it's cubed, so multiplicity 3. Okay, so we see where our multiplicities come from. They come from factored form. How many of them are there? There's 2 of the x minus 3's, and there's 3 of the x's. Yeah. What? Oh yeah, so we said that there are 5 zeros, which that makes sense, right? If there's 5 zeros but I only have 2 factors. What was that again? Huh? Yeah, I'll say that again. If there are 5 zeros, we figured out there was 5 because there's one that was 5, but I only have 2 factors. The multiplicity is where we add to 5. So 1, 2, 3, 4, 5. So you could rewrite this as x.
The greatest degree. That was a close one.
X times x times x, x minus 3, x minus 3. So I actually have 5 factors. But there's 3 x's, 0 multiplicity 3, and 2 x minus 3's, and that x cubed. That's what x cubed means. Well, I know. I was just repeating it. What do you notice about your answers? And that's what you said. I noticed. The multiplicity gave me my 5 zeros. Okay, I really want to go over something at the end. I'm going to give you guys a worksheet or like a cheat sheet. What's that? Study guide type thing at the end. So let's just do this together to show you where the multiplicity comes in.
Oh, I thought you were like showing us what
I'm going to copy this. Oh my gosh. Okay. Copy that on there. What is happening at x equals 0? So does it go through? It goes through. Okay. At x equals 0, the line goes through. At x equals 3, what happens? It bounces. At x equals 3, it bounces. We noticed that our multiplicity was 0 multiplicity 3. and 3 multiplicity 2. What's the difference between 3 and 2? Odd versus even. So with odd multiplicity, it went through. At even, it bounced. What? It is only Tuesday. Wait, let's go back here. There's a lot to go on over today. Okay, so we're going to answer all of these questions like we did last time. You're fine. Hey, Ben. Where's our vertical asymptote on this graph? So it's a vertical asymptote.
Is it 3 multiplication 2?
I like that. 3, but we're going to make a note, multiplicity 2. We're just going to think about that for a minute. It's going to be 3. Okay? But I'm going to show you what's going to happen with this multiplicity, yes. Because of the exponent around those parentheses. There's 2 different x minus 3's. Yeah. Yeah. Are there any holes on this graph? No. Nothing was reduced, correct? Now the horizontal asymptote. What did you say? 0, because the degrees are not the same.
Oh my goodness, that's why it equals 0, because the denominator is bigger, right?
Yeah, so the denominator's degree is 2 because it's squared. So if your denominator's bigger, your horizontal asymptote is y equals 0.
Bless you. Bless you.
Oh, it's where it bounces is the x-intercepts. Okay, x-intercept.
Should I be listening? I'm not listening.
No, you're good.
-1,
How do I write that?
0.
-1, comma 0, y-intercept. There are. Okay, let's write this out. 0 plus 1 over 0 minus 3 squared equals 1 over -3 squared equals
Oh, right.
1/9.
1/9. So our coordinate pair is
0, 1/9.
good.
Which is a little baby fraction.
We are not going to plug in points. We're going to start graphing. Your vertical asymptote is That's a good question. Okay, now I need you. Summers. Now I need you.
Okay, yeah, I'm listening.
I'll bring you up to speed. We have the horizontal asymptote is y equals 0 because the bottom degree is bigger.
Got it.
But we have a x-intercept,
At -1.
a -1.
Yeah,
But there's no other,
I got you.
yeah, okay.
I got you. Okay, well, this is just an obstacle course, okay. Okay, so here's what I know. I'm gonna do it without a table, but I need more attention than Hooper needs. Because I'm needy for attention. Ben, I'm needy for attention. Eva, I'm needy for attention. Okay, I'm gonna do it without the table. You ready? Have you talked about multiplicity, how it applies to asymptotes yet? Okay.
No, this is what I was bringing it up.
Okay. Well, we need to do that first. What? Maybe. Do you think you should?
If it's a pun, shut up. It's not a pun.
He's been making puns all
No, I haven't. Okay.
Okay.
Why should we have to go, like, why should we have to fulfill the need?
Would you rather me do what normal teachers do and do like a clapping thing to get your attention, or yell and be like, "Shut up"? That is my humor classroom management way of saying pay attention. And I don't know if I'd say that's a funny comment. It was kind of a disrespectful comment.
I had more than put on.
Oh, okay. Well, this I've given too much time for, so we're going to move on. Okay? Method to my madness, my friends. All right. Listen. Hey, I need attention. Fulfill my need for attention. He wasn't even watching now. Okay. Steven!
What?
I would like you to fulfill my need for attention.
Okay.
Thank
Yes,
you.
ma'am.
Yeah, that's right. Okay. Okay. Well, I need everyone's attention because this is the trickiest part of the lesson. You with me? All right. When my x-intercepts had an even multiplicity, could they cross the x-axis?
No.
Drake says no. Does anyone else agree? What do you think, Jonah?
Could they bounce off the top?
They could bounce off the top or the bottom, right? But that was for x-intercepts. You with me?
Oh, that's right.
Wait, so could they bounce if it was a pod?
No, they cut right through. Mm-hmm. So what we call that with math terms is it has a sign change, like a plus or minus sign change, right? So if it bounces, it's because it's staying positive, 0, positive, or negative, 0, negative. You with me? Does that make sense? Review, right? Okay. We can't do the left side of this graph until because it's weird here, okay? But we're gonna do the asymptotes first. Here's the only thing I know right now. You with me? The only thing I know right now is that the x-intercept cannot have a bounce, right? Right now, that's the only thing I know. Does that make sense? You guys, this is hard math. So if you're not giving me 100% attention right now, you're not going to understand it. Okay? Does that make sense with everything we've been talking about? Can I come back down and cross the x-axis again between 0 and 3? I can? Where? No, I can't, right? Because I didn't find other x-intercepts there. You with me? So don't I know that this has to go up this way?
Yes.
Has to, right?
But it can't cross the road of glasses.
Right. So it has to just kind of go kind of parallel to it, like Sam was saying earlier. I heard that. I was like, parallel. Oh. Okay. Now, what is the multiplicity of this vertical asymptote here? 2. Is that even or odd? So it cannot have a sign change. You with me?
Yes.
So if it cannot have a sign change, instead of going positive, 0, positive, like on an x-intercept, it's going to go positive, undefined, positive. That's the weird part, right? So can you agree that this part of the graph either is going to look like that or like that, right?
Yeah.
But one of those,
They can't.
it can't be because of the even multiplicity. Do you see how on this one here, my vertical asymptote is approached with a sign change?
Because you think it's going down when you first start graphing it, but then it actually goes up. Is that what you're saying?
Yeah, because look, this one's approaching infinity and this one's approaching negative infinity.
Which
So,
is what your domain tells you.
no, not yet, because that's just the x's. I'm just saying, forget about everything else on the graph. Just look at the vertical asymptote. Okay? Jenna, you with me? With a smile? Okay, then what's your question?
I'm so lost.
Okay, but what part are you lost on? This.
All of it. Like, it just sounds like you're speaking a foreign language to me right now.
Okay, what's a vertical asymptote?
The excluded.
Excluded values.
Okay, well, that's part of it. But what does the line vertical mean?
Up and down.
Okay, up and down. So the only up and down line here is this red one right here. Does that make sense? That's the vertical asymptote? Okay. Now, sign change, that idea is a new word for everyone today. Okay. You guys, again, this is hard stuff. So if you haven't been making sure it makes sense from 4.1, it's going to be hard for you today. Okay. All right. What, Kendra? Oh, okay. Okay, I'm sorry, your pomegranate rolled on the floor. Okay. We just defined the new word sign change. So what did that mean? Sign change. Airly? It's where it's positive or negative. So around the vertical asymptote, do you see how this picture right here has a sign change? Positive, undefined, negative. Right? But what did we say about even multiplicities? They can't. So this cannot be that part of the graph.
It has to be the upper part.
Yes, because it cannot have a sign change because of the even multiplicity. It's the bounce version of a vertical asymptote. You with me?
So it's kind of just like a mirror.
Exactly, because anything squared stays positive, right? So around the vertical asymptote, because of that too, it stays even.
That makes sense.
Ah, okay. Here's the weirder part. I cannot bounce at the -1, right? But I have to approach the horizontal asymptote, right? But remember, the horizontal asymptotes are the behavior asymptotes, not math error asymptotes. So sometimes I cross them. And you guys are always like, well, how do I know? And I'll say, when you have to. Here's a time you have to. Because I have to cross because of that x-intercept, but eventually it's going to have to come back up and have a bend in it. I want to show you what it looks like here. Wait for it. Y equals. Okay, look. Do you see how this is our horizontal asymptote at 0? Right? But it crosses and eventually we'll have to come back up. You with me? Because it doesn't, the x-intercept didn't have a multiplicity. Well, it's a multiplicity of 1. So I have to have a sign change. Positive, 0, negative. Instead of a bounce. Okay? Oh man, what a good question. What if the x-intercept had a multiplicity? So you're asking, what does the graph of that look like? Okay, let's take a look. My vertical asymptote here, my horizontal this time would have been at 1, right? Because it would have changed the degree. You with me? Because it'd be x squared over x squared now.
And then the coefficient is just
1, because there's nothing there. Uh-huh. This one would have gone up here because we know it can't cross the x-axis again, right?
and you know it can't cross the x-axis
Because I didn't, when I solved for x-intercepts, I only found one at -1,
because
right? So then this one would have come down here again, crossed the horizontal asymptote, bounced right there, and come back up.
okay.
Good? If you guys don't like the shape of the graph thing, like problem solving through it, you can do a table. The table just takes longer. Does that make sense? You guys, this is hard stuff. It just is. So if you really are struggling and you're not letting us help you as you go through, every person that has come in during lunch and sat next to me and let me walk them through a problem, when they leave has been like, wait, that's not as hard as I thought. I'm like, yeah, I know. I know. We are past the point in math where we can listen to every 3 words our math teacher says. We must listen to all of them. Anything else? Or do you want, what do you need? Done? Is that all?
Yeah, I was gonna put the thing on the back.
Oh, perfect. Yeah, this is going to be helpful. You're going to like it. I don't even know. I heard Arlate say, can we do the domain? Was that for a different question? That's fine. Well, I just estimate based on your graph. My graph on this one would be an estimate from like -1 to infinity, but on this one it would have been 0 to infinity for sure. But on the ones where I don't care if you know exactly how far down that goes, that's a calculus concept to figure that out. You just take a guess. Does that make sense? Yeah? Cool.
I feel like
All right.
if we try one more together, it might make more sense.
We don't
I
have
don't know if we
time.
have time to do that.
Well, you have the choice. Do you want to try one more altogether, or she's about to give you a summarization list of everything? I think you want this.
Okay, the very back, turn it over and write on the blank page. Yeah, I can totally speak English.
Review next time.
Okay, these are your steps. These are all the things you have to find and how it should look, the notation, everything, okay?
So let's stop the recording
Okay.
and then start it up again.